All right, so let's check the audio. Hopefully, the audio will work. Okay, sounds good. Finally, the audio is stabilizing. Absolutely horrible. Okay, so we're not sharing the right one? Oh, no, we don't want to share this. We want to share. What do we want to share? Okay, oh, this. Okay. Oh, no, we don't want to share it. Tee la 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 la. All right, let's look at some dance moves. Has an awesome body. She's amazing. All right. All right. Let's go. So, in the previous video, I think I was watching one of these episodes. I guess it's from Caltech, The Mechanical Universe or something. That's a good name. So it was episode 42. I think we're looking for episode 43. Or maybe, I don't know. So what they said in the episode that I watched, they said that Einstein claimed at the end of that episode, I almost lost my mind. Let me look for that. I don't know if it was this or this. Let's take a look at this one.
Had reached a state of perfection. He sought, but refused to accept.
One is that Michelson, of course, the Michelson-Morley experiment served some pedagogical purpose. Physics in historical.
And the solution he sought, but refused to accept, Albert Einstein's theory of relativity, would change forever the very meaning.
That's Michelson. So he could not understand why he was getting, basically, he couldn't see the ether in his experiments for the rest of his life. I mean, he spent the rest of his life just he couldn't get it. Why was he not seeing the ether? People don't understand. It's impossible that there is no ether. Michelson had it right. Einstein got it completely wrong. And everyone followed Einstein into the gates of hell.
Of space and time.
Einstein came up with utter nonsense. Einstein's theory is unscientific. It's not mechanical. The premises are pulled out of thin air. Nothing makes any sense. This is a miniature version, I guess, of the Michelson-Morley experiment. This is where the light comes out. Forget, it's not important.
We often teach physics in a historical way. The purpose, of course, is not to teach history, but to teach physics. And so, very often, we redesign the history. We tell you not what really happened, but what should have happened.
This is terrible. This is terrible that instead of teaching the truth, they're teaching lies. And it's so difficult to find the truth because everyone is teaching their version, which is a lie of reality. So it's almost impossible to know what really happened unless you basically have to become an archaeologist and a detective and figure out what the heck actually happened.
Well,
And I'm talking about how did Einstein, what happened that Einstein took over the world? What happened?
I suppose that it serves some pedagogical purpose to do that. So let me tell you what should have happened at this point. There should have been a patent clerk in Switzerland named Albert Einstein who should have said, look, the Michelson-Morley experiment compels us to do two things. One is to restore the principle of relativity.
Wait, what do you mean restore? What do you mean restore? Which principle? Which relativity? I don't know what he means.
And the other one is to believe that the speed of light will be the same to all observers, regardless of their state of motion. And from those two fundamental postulates,
No, no. These are not fundamental postulates. No, no. Michelson-Morley should have been explained separate of anything. It just should have been explained. You just need to explain Michelson and Morley's experiment. You just need to explain it. You notice the phenomenon, and then they said that other experts repeated it and with even more detail and more precision, and all they could do is reproduce the null result. So at this point, you have to say, all right, let's begin the scientific method. Let the scientific process go to work. So we've noticed a phenomenon that keeps repeating, and we simply cannot explain it. We cannot understand it. Fantastic. That's the most difficult part, I would say, to get. All right, good. Now, let's explain it. Let's build a simple mechanical model to explain it. It's so simple. I mean, it might be difficult, but if they would have tried, I'm sure they would have succeeded. But you have to try. You can't just say, the speed of light seems to be constant for all observers. That's a postulate. Go jump in the lake. That's not scientific. That's not science. That's not science. What is that? That's nonsense. What the heck is going on? This is not science. You need to explain a phenomenon. That's your job. What are you getting paid to do? You had 120 years. So by now, this is from Michaelson-Morley. This is like 1880 or something. This is right after the Civil War. This is like 10, 20 years after the Civil War. You've had all this time to figure it out. It's not that difficult. And all you can do is, well, that's what we noticed. Hey, we don't know what causes it. The speed of light is constant for all observers. That's a postulate. I'm a scientist. Hey, look at me. I'm a scientist. I can repeat the data. Hey, isn't that being a scientist that I can just regurgitate the data? Oh, I'm so smart. I noticed a phenomenon. I'm not going to explain it. That is science. What the heck is going on? This is why we respect Einstein? Because he's unscientific? What the heck is going on? This is out of control. I can't believe it. I just can't believe it. This is in direct violation of my proposition 90. It's called Bacon. You're not following Bacon's algorithm of science. So whose algorithm of science are you following? This is not science. You have a phenomenon. Can you please explain it? Not contain it in a postulate as an assumption, as a given. Well, what is this? Mathematics? You have a phenomenon. How difficult is it to explain it? This is a total shite show.
follow all the astonishing.
All these students are sitting there quietly. This is terrible. This is terrible. You should never do this. Never sit in the class and just be quiet. And if it's not, you're not coming to class to listen to a lecture. You can read the notes, write a book, I'll read the book. I'm not here for that. I'm here to ask questions. Stop the nonsense. I have a question. Stop the nonsense. Answer this. You got to answer. Until you answer, we're not moving forward. Nothing. I don't care whatever else you discovered. I don't care. We need the fundamentals. We need the foundations. Unbelievable. And look, all the students, they're just showing pretty faces. Oh, look at this pretty face. Oh, look, none of the students is talking.
Results of the theory of relativity.
Look at how quiet everybody is. They're like, we're absorbing the truth from the gods. The gods. At least this guy, this teacher, is not so bad.
Now let me tell you what the facts were.
This is incredible. This teacher is incredible. He's telling them We should have expected Einstein to say, okay, look, okay, we have the Michelson-Morley experiment results. Let's just take it as it is. It is what it is. Let's continue from there. The speed of light is constant for all inertial, whatever, observers. Let's start from there. Okay, we'll get whatever we'll get. Fine. But that's not what happened. Here is what actually happened. And listen to this. My jaw hit the floor so hard that I thought I need to run to the hospital. Listen to this.
One is that Michelson, of course, never for the rest of his life believed the results of his own experiment.
This is incredible. Michelson is the true scientist in the room. No one else.
But the other one is that Einstein not only didn't base his theory on the Michelson-Morley experiment.
He didn't base his theory on the Michelson. Not only didn't base his theory on the Michelson-Morley experiment,
but he later claimed that when he wrote his famous paper in 1905, he had never even heard of the Michelson-Morley experiment.
In 1905, he had never even heard of the This is about 25 years or something like that, and he never heard of it. This is a guy that has done nothing but think about what is light since he was, I don't know how old, 16 or 6 or who knows what. And he never heard about the Michelson-Morley experiment? What? The most counterintuitive experiment in the history of ever? This was so simple. They should have gotten the result for the speed of the ether. And they got nothing? And you never heard of it? I don't believe it. I don't believe it. I don't believe it. This is unbelievable. So he just let's postulate. So Einstein in his paper, he just postulated the speed of light is a constant for all observers. What? Based on what? I kept asking, what did he base it on? What did he base it on? Michelson-Morley? Everybody knows he had no references in his paper. So he can't base it on anything. So what did he base it on? Nothing? How is that possible? How is that possible? As a foundation? As an assumption? As a postulate? What? That's impossible. And no one raised an eyebrow? What the heck is going on here? This is too much. This is too much. This is just too much. You let scientists, you say, this is literally game theory. This is the principal agent problem. You assign science to an agent as a principal, you pay the money and you say, you take care of that. I'm gonna get busy making money. I'll give you some of the money so you can concentrate on science. And what do? They accept this paper from Einstein that has no references, that starts from a postulate that the speed of light is constant for all observers as a postulate with no reference to Michelson-Morley? What? And you had 100 years and 120 years to look at this, and it never bothered you? Jesus, I don't know what to do.
Now, we'll see how that was possible when we go on with this next time.
We'll see how that was possible? Okay, all right, I'm open-minded. Maybe I'm wrong. I don't know anything. What do I know? Okay, this is episode 41. So I started listening to episode 42. Is it here? There it is.
Between mirrors.
Possible clock could be generalized. One possible, and Edward Morley.
This is so touching.
Last time, I told you the conventional history of relativity. There was the theory of...
So his name is Dr. David L. Goodstein, California Institute of Technology. California Institute. Does it have a name?
the ether, And then the Michelson-Morley experiment showed that it was wrong. And then Albert Einstein produced the theory of relativity. As I told you then, that story is logically correct, but not historically correct. Well, what is the real story? I'll get back to that in a little while.
Why don't you just tell us the real story?
First of all, I would like to tell you about a part of the theory which is still called the Lorentz transformation.
That also makes no sense. Einstein, I don't think, referenced Lorentz. I don't think there's any references in his paper. I don't know what's going on. Maybe I'm wrong. Maybe he did have references.
In the Lorentz transformation,
Hold on. Let me look up Einstein's original paper. Einstein's paper on SR. Special relativity. I want the original paper. In 1905, Albert Einstein published his groundbreaking paper Zur Elektrodynamik bewegter Körper, on the electrodynamics of moving bodies, which introduced his special theory of relativity. This paper reconciled Maxwell's equations for electricity and magnetism with the laws of mechanics, introducing significant changes to mechanics near the speed of light. Key findings. I don't care. I want to see the paper. The paper presents the famous equation E equals hf, establishing the energy of light quanta. That's Planck's formula. Einstein's special theory of relativity is introduced, which posits that the laws of physics are the same for all observers in uniform motion relative to one another. Is this what it's based on? The paper mentions the names of only 5 other scientists: Isaac Newton, Maxwell, James Clerk Maxwell, Heinrich Hertz, who found the waves, he discovered electromagnetic waves, radio waves, I think. Christian Doppler from the Doppler effect, and Hendrik Lorentz from the Lorentz transformations. Notable aspects. At the time, citations were not common practice in scientific papers. And Einstein's paper did not include explicit references to previous research. Despite this, Einstein's work was well received by the scientific community, and his theory of special relativity went on to revolutionize our understanding of space and time. Impact. Einstein's 1905 paper on special relativity laid the foundation for modern physics, influencing numerous areas of research, including particle physics, cosmology, gravitational physics. Its significance extended beyond science, with far-reaching implications for philosophy, engineering, and technology. Where's the paper? Wiki. Annus Mirabilis papers. Where is the paper? Maybe Google Scholar? How can you get the paper? I want to put my hands on this paper. Einstein's special relativity is a theory of invariance, not relativity. Source. For sure, invariance theory would have been a better name. The Einstein Papers project is set up to be the definitive source of historical. I don't know if this paper is going to help me, because if it was not common to cite previous work, then of course it has no references. So, but he said he never heard. But Lorentz isn't Lorentz based on? Isn't Lorentz based on the Michelson-Morley's experiment? That's all he did. So didn't Lorentz, if you read Lorentz, wouldn't you know about the Michelson-Morley? Wouldn't you want to, wouldn't you hear about Michelson-Morley? I wish I could take a look at this. How could you not have heard about Michelson-Morley? What role did how did Einstein's special theory of relativity change? How did Einstein okay, let me see. I want to download Einstein's paper on special relativity. Can you just give me a link? In 1905, all right. Results for download. Princeton. Digital Einstein Papers Home. Collected papers of Einstein brought to you by Einstein. Let's try this. T la 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 la. The collected papers. The early years. Okay. All right. Should be here. It was 1905. The Swiss years. Writing 1919. Okay. So we need the electrodynamics one. Conclusion drawn from phenomena of capillary on the thermodynamics, kinetic theory of foundation thermodynamics, on the general molecular review of. So he was busy. He was a scientist apparently. Review of William. Okay, review. So he reviewed. So maybe we can just find here Michelson. No, it's not here. Morley? No. So he doesn't. There's no paper reviewing Michelson-Morley. Okay, so just let's look for electro. One second. Electro. There it is on the electrodynamics of moving bodies. T-la-la-la-li-la-la. Yeah, so you go to the right. Okay. How many pages is this? Oh, it's in German. That's not going to be possible to understand. Interesting. He uses tau. There's beta. Fascinating. Albert Einstein, electrodynamics of moving bodies. Okay, but where do they have a translation? Well, it's good that we have the original. How many pages is this? I thought it was much short. I thought it was like a few pages. Okay. All right, that's too much. I need an English translation. All right, let's go back. T la 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 li la 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 li la la. Back. All right. Okay. So we need the English. Are these just the originals? Related, partners, about. I don't think there's an English translation. Oh, here it is. Here's the English translation. Okay. So again, on the electrodynamics of moving bodies. Let's try refreshing. I might have hit escape. Okay. So okay. Okay. So it was published, I guess, inside this periodical, pages 892 to 921. So 21 plus 8 is 20, almost 30 pages. So it's about 30 pages. Okay. It is well known that Maxwell's electrodynamics. Can we do a search? Let's look for Michael. Michael. Sorry. No, that's not how we spell. I think it's Michael. Mikhail, nothing. What about Morley? Morley, nothing. Ether. What about ether? Okay, there it is, ether. Dialectic ether. So conclusion drawn from the phenomenon of capillary by Albert Einstein. Okay, conclusions drawn. Review. Heuristic. Okay. Let's look here for electrodynamics of moving bodies. All right. Basis of Maxwell's theory for bodies at rest. The introduction of a light ether, the luminiferous ether, will prove superfluous. That is unscientific. Inasmuch as, in accordance with the concept 2.6 be developed here, no space at absolute rest, endowed with special properties, will be introduced. No one is talking about anything absolute. We're talking about relative to the ether. Why do you even mention the word absolute? Nor will a velocity vector be assigned to a point of empty space at which electromagnetic processes are taking place. That's utter nonsense. That's unscientific. That's magic. Like every other electrodynamics, the theory to be developed. Okay, this is page 141. How's the audio? Okay, the audio is good. And is anyone watching, or are we always alone? We're always alone. Nobody cares about anything. I mean, this is actual research into what the heck happened to science. What the heck happened to science? All right. So we was here. We need to go to page 141. Page 141? What is that? There is no page 141. Can I just click it? Okay, page 141. There it is. Basis of Maxwell. Okay, the introduction of a light ether will prove superfluous, inasmuch as, in accordance with the concept to be developed here, no space at absolute rest, endowed with special properties, will be introduced, nor will a velocity vector be assigned to a point of empty space at which electromagnetic processes are taking place. Like every other electrodynamics, the theory to be developed is based on the kinematics of the rigid body, since assertions of each and any theory concern the relations between rigid bodies, coordinate systems, clocks, and electromagnetic processes. Insufficient regard for this circumstance is at the root of the difficulties with which the electrodynamics of moving bodies must presently grapple. Kinematic part. Definition of simultaneity. Consider a coordinate system in which the Newtonian mechanical equations are valid. To distinguish it verbally from the coordinate system that will be introduced later on, and to visualize it more precisely, we will designate the system as the system at rest. If a material point, the question is where did he make the assumption that the speed of light is a constant? Let's look for, I mean, actually, let's look again for ether. Hold on. Let me search again ether. And now let's search for electro. But there's 9 of them. So let's search for the next one. Electro. Okay. We need to look for the title on the electro. Okay. On the electro. How many of the? Oh, there's only 2. So what is this? He seems to. Wait, what is this? on the development of our views concerning the nature and constitution of radiation by Einstein. Swiss years, okay. The theory consists, why is he mentioning deformation velocity of parts of ether? This theory introduces into consideration the electromagnetic states of ether theory. According to both of these theories, light waves. Didn't Einstein in his later years come back to the ether? Hold on. Maybe he was trying to. Maybe he felt bad and he was trying to backpedal the original special relativity, but it became too popular and he couldn't stop it. It was bigger than him. I don't know. So did Einstein, what did he do? Did he or did he not believe in the ether? What do people think? Did Einstein? Okay, based on the search results, Einstein stands on the ether evolved over time. Initially, he rejected the concept of the luminiferous ether, which was a stationary medium. Jesus Christ. Thought to transmit light waves. The rejection was a cornerstone of his special theory of relativity, as it challenged the ideas of an absolute reference frame. Early rejection, 1905. Einstein denied the existence of the ether, citing the Michelson-Morley experiment's inability to detect it. He did cite it? What the heck is going on? So now I'm getting conflicting evidence. He argued that the experiment's null result demonstrated that the ether did not exist, as it would have affected the speed of light depending on the direction of motion. Later consideration, 1920. This is after GR. However, in his 1920 lecture, Ether and the Theory of Relativity, Einstein revisited the concept of the ether. He acknowledged that in general relativity, the gravitational field can be thought of as a kind of an ether. That's exactly what I thought. Jesus. So he agrees with me. That's exactly my theory of general relativity that permeates space-time. Jesus Christ, this is everything I'm saying. So he already said. All right, so he's not a complete dummy dum-dum. This relativistic ether concept differs significantly from the classical notion of a stationary medium. Okay, Einstein saw this ether as a physical property of spacetime, which can be identified through geodesics. Key takeaways. Einstein initially rejected classical concept of the lumina as it conflicts with his principle of relativity. It doesn't conflict. That's not true. Later, in the context of general relativity, Einstein introduced a new concept of an ether, a gravitational field that permeates spacetime. This relativistic, I can't believe it. So I've come a complete circle. So Einstein agrees with me. This relativistic ether, so he did understand everything. So people make fun of me because I actually agree with Einstein. Well, that's good to know. At least I agree with. So people attack me for being a dummy dum-dum because Einstein disproved the ether, and here is Einstein saying, "Yeah, the fabric of space-time. Yeah, that's the ether. It's fine." Oh my God! This relativistic ether is fundamentally different from the classical notion and is not stationary medium. That's fantastic. Well, they never thought the ether was stationary. They wanted to to detect the velocity of the ether. That is Michelson-Morley experiment. In summary, Einstein did not believe in the classical concept of the luminiferous ether, but he did propose a new relativistic understanding of the ether as a physical property of spacetime in the context of general relativity. Okay, so that's I need to quote. When did he say this? In a lecture? In 1920 lecture? So we need to find the notes whoever took note, 1920, didn't they already record lectures? Ether and the Theory of Relativity. So he actually gave a lecture, Ether and the Theory of Relativity, with a comma inside the quotes. Why would you put a comma inside the quotes? All right, let's search this. Share. Always share. Ta-li-la-la-la-la. Ti-la-la-la-la-la-la-la-la-la. Ta-di-na-na-na-na. Where were we watching? I guess here. Okay. Okay. Ether and the theory of relativity. According to the general theory of relativity, space without ether is unthinkable. Exactly. In such space, and it's the word space, there's no time. Such space, in such space, there would be no propagation of light, and therefore no possibility of existence for standards of space and time measuring rods and clocks, nor therefore any space-time intervals in the physical sense. Exactly, it's too rigid. Albert Einstein's special relativity rejected the ether theory, positing that ether does not exist. This was a significant departure from the prevailing understanding of the 19th century, where ether was believed to be a necessary medium for the transmission of electromagnetic waves. So Einstein agrees with me. So I've come a full circle. I've come a full circle. So he was not a dummy dumb dumb after all. But why didn't people take him seriously when he said, okay, GR is the ether. Let's bring back the ether. The Michelson-Morley experiment, 1887. So it's, I don't remember when was the Civil War. This is a few years after the Civil War. Weakened the ether theory by failing to detect the motion of the Earth through the ether. This experiment, designed to detect the ether, showed no such effect. Let me take a sip of water. Okay. The formulation of special relativity by Einstein in 1905 and the subsequent acceptance by scientists led to the abandonment of the ether hypothesis as being unnecessary. In contrast, the luminiferous ether concept, which posited that light travels through a medium, was a pre-Einsteinian idea. Michelson and Morley interferometer. The interferometer is just the contraption with the mirrors. That's an interferometer. So if you get an interference, it is designed to detect an interference pattern. It's basically designed to detect the speed of the ether. Okay, Michelson and Morley's interferometer experiment aimed to detect the ether, but they never found evidence of its existence. It wasn't until Einstein's special relativity, 1905, that the physics community began to accept that the ether does not exist. That is such nonsense. I think Einstein wanted to basically tell them, look, GR proves that there is an ether. And he could have showed them that the ether, you can explain the ether with special relativity and actually get a better explanation. And then you don't need to just assume the speed of light is a constant. So it's actually, you can propose a new special relativity. You can propose, somebody should write a paper that proposes, takes the original theory of special relativity and says, now let's explain it with the ether. That's all. And now let's propose to conduct. So I have a proposition to discuss the speed of the ether. So I gave my proposition the other day. Share this. Let me just review it because I drew a picture. La 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 la. Let's see, where is it? So Is it this one? I don't know. Or this one? Michelson and Morley. I think it's this one. Yeah, here it is. Let's review it quickly. So basically, how do you discover the speed of the ether? So the speed of the ether is the speed of space. But then they would say, yeah, but that's not the speed of waves because I'm discussing particles. We need to discuss the speed of waves, or the speed of light. We need to show that the speed. Anyway, the point is you take a building and you put a vertical particle accelerator on it. Either it's circular or it's linear. The point is that at the bottom, at this area, you're doing your experiment. You accelerate the particles to a certain velocity. There's going to be 3 velocities. Oh, wait. My new beautiful girl. Oh, fantastic. Fantastic. Da-dee-da-da. La 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 la. That's great. That is good news. Okay. So then you take this area at the bottom. This is where you're going to conduct the actual test. So in the area where we conduct the test, there's going to be particles moving in. You're going to be accelerating particles to 3 velocities. One of them is about 10% the speed of light. That's the calculation we did the other day of the speed of space, which is the speed of ether. That's the speed of ether. It should be about 10% the speed of light heading towards the center of the Earth, of course. So you're going to be dropping particles at V, or accelerating particles to this region to V, some of them less than V, V minus, and some of them V plus. All right. So they're going to reach this area. When they reach this area, you stop accelerating them. You just let them fall. Now they're falling with space, with the ether. As they fall with the ether, so you just check their age. So there's going to be a stream of particles. So at a certain velocity, you check their age, their incoming age here. Then you check their outgoing age, and you calculate by how much they aged, if you can do that. By how much did they age? And you plot it. So at this velocity, they age this is delta A versus this is delta A versus the velocity. So we should get at 10% the speed of light, the maximum aging, because that's when their clocks are ticking the fastest. So each particle can be viewed as a clock ticking. So as it moves at the speed of space, so it ticks the fastest. But if space, or if the ether flows through this clock, through a particle, either faster than, it's either moving through the particle this way or moving through the particle this way, it's going to slow down the particle's aging. So if the particle is moving at the speed of space, and the speed of space I calculated to be 10% the speed of light. So if it's moving at the speed of space, you should be getting the most aging. It should age the most. And any other speed of the particle should age less. That's it. That should prove the speed of space. Now, next we need now to think about how do we prove the speed of ether. That's a good question. How would we prove? I didn't think about that. The speed of the ether. My intuition is to do the same with light. So if you fire a light beam, but the light beam, you're always going to fire it at the same speed. It's always traveling through at the same speed. You cannot what can you do? I mean, I don't know what to do. I need to think about it. Let's continue. I'll have to think about because I already thought about it. This is just the speed of space. This is not the speed. The next step is to prove this is ether. How do you prove this is ether? That's okay. I'll think about it. But this is already. This is worth a Nobel Prize or a PhD or both. So enjoy your winning. Where were we? We were looking. Oh, we were reading this. Okay. So, in summary, Einstein's theory of relativity rejected the concept of ether, instead positing that space and time are relative and intertwined. That's utter nonsense. The Michelson-Morley experiment and subsequent developments in relativity theory led to the abandonment of the ether hypothesis. No, I have not abandoned it. And neither did Einstein, marking a significant shift in our understanding of the fundamental nature of space and time. That's nonsense. That's absolute nonsense. We just became idiots. We started believing in magic. All right, so this should be Einstein's lecture. So we saw that he gave a lecture. Let's look for his lecture. Okay, let's look for this lecture that he gave. Einstein, Ether and Relativity, McTutor. Albert Einstein gave an address on May 5th, 1920 at the University of Leiden. Where is that? He chose as his topic ether and the theory of relativity. This is after GR. He lectured in German, but we present in English translation below. The lecture was published by Methuen and Co. All right, so this is math history. Let's see if we can put our hands on this. All right. Sorry about the bright light. I'm sorry. I'm sorry. My eyes are hurting just as much as yours. Okay, Einstein, ether and relativity. Albert Einstein. Okay, so ether and relativity. So how long is this? So what are we looking for? I mean, I already read enough. This is the entire lecture. These are his notes. So it was a quick lecture. Recapitulating, we may say that according to general theory of relativity, so that's how you used to call it? It was in German. To the general theory of relativity, space is endowed with physical qualities. That's it. In this sense, therefore, there exists an ether. What else do you want me to say? According to the general theory of relativity, space without ether is unthinkable. What do you want me to say? What do you want me to say? For in such space, there not only would be no propagation of light. What do you want me to say? But also no possibility of existence for standards of space and time, measuring rods and clocks, nor therefore any space-time intervals in the physical sense, of course. I can't believe it. And everyone just ignored this lecture? He should have written a paper and submitted it and tell people, hey, look at this paper. This would have resolved quantum. This is the foundation of that quantum physics needed. But this ether may not be thought of as endowed with the quality characteristic of ponderable media. What? As consisting of parts which may be tracked through time. No, you're wrong about that. Oh my God, he misunderstood it. The idea of motion may not be applied. Oh, he misunderstood it. He misunderstood it. He misunderstood it because he didn't understand general relativity. He misunderstood it. So he says you can never detect the motion. So first of all, I propose the experiment that he's wrong, that this statement is wrong. The idea of motion may not be applied to it. Jesus, I can't believe I could just read through Einstein completely and thoroughly understand his psychology. I know exactly what's going through his mind. He misunderstood the curved geometry, and he called it curved space, and it completely threw him off. It's not curved space, it's curved geometry. The space is moving. Of course it's moving. This is so exciting. This is so exciting. Oh my God, I gotta. Oh my God. Oh my God. Oh my God. I gotta send this. I gotta send this to. And I gotta call someone and have a discussion about this. Ta-dee da 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 da. Ta-dee da 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 da. Ta-dee da la 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 la. La 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 la. La 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 la. Tirana. Tirana. Okay, we're gonna stop here because I gotta make a phone call. This is sort of exciting. It's sort of exciting. It's exciting enough that I gotta make a call and talk to someone and get this off my chest. We'll continue. We'll come back in in bigger numbers. See you later. Bye bye.